Yesterday, we talked about the equations again. We had review of equations. We did some of the super easy ones, right? Those like very first questions where it was one-step equations or two-step equations and you all could get the answers like super fast. And then we did some of those tougher ones where it was kind of a review of yesterday and maybe the day before, where we had variables on both sides where we had to plug stuff in. If you remember yesterday, we only had that one question where we had to actually graph the lines and see where the two lines crossed. Right? And I said how they were kind of jerks when they wrote those questions because they didn't put it in the right format. They didn't have the y equals. You know, we had to move some stuff around, and it was actually pretty tough. To be honest, that was kind of a tougher version of the question that we're going to do today. So what I want to do today is focus more on the questions where we have equations that we have to graph. We're going to graph all our stuff today. Obviously, I have the paper up here. You're going to get a paper in a little bit. And we're going to attempt to graph the equations. We're going to have to remember the things we learned earlier in here about slope. We watched the movie, talk about rise over run, positive slopes, negative slopes, y-intercepts, and then up so many and over so many, or down so many and over so many. We're going to use those skills to graph two lines and see where they cross, if they cross. Sometimes they won't cross. And if they don't cross, we will use our fancy answer that we had the other day. No solution. And sometimes we'll graph two lines. I don't think it'll happen on today's assignment, but it is possible to graph two lines that are the exact same line. And if they're the exact same line, that's when we say
infinite solutions.
Yeah, infinite solutions, because every single point on the line is the same because they're the exact same line. So I've got this kind of double-sided deal. I'm not sure if it will be too many questions, not enough questions. Like some of these are the same that Mrs. Dean used in her class yesterday. If you have friends who had her. She didn't make the paper quite as small as I did, so I apologize if this isn't quite, the best way to set it up. But we have a front and a back. One side says Algebra 1 at the top. The other one says Pre-Algebra at the top. To be honest, there is no difference, so don't get freaked out. If you see, ooh, Algebra 1, it's going to be really hard. No, it's actually easier than some of the questions we did yesterday. Yeah. Okay, so we'll try to get this accomplished. If we are super awesome and we can get all these done, I would be happy. If we can just get as far as we can and we don't get all the way done, that's okay too. If we are incredibly amazing and we do all of this, we may have a chance to go back. Remember, I had those questions yesterday we didn't finish, like we stopped at part A on that one number 9 one. We'll just get as far as we can, and if we have a chance to finish those from yesterday, great. And if not, well, we might look at it, maybe doing that tomorrow. Questions before we roll? All right. Let's start on the side that says Algebra 1 at the top, actually. So I'm going to try to give it to you with the side that we're going to start on, because they look almost identical. So don't start flipping and flopping and all sorts of weird stuff with your paper, because then you may end up on the wrong one. Still here. You got it ready. I guess you could use it today. You could use it today. 21st. 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 Do this. Whoa. So go ahead and put your name on there so we don't end up with some type of missing paper situation. I'm going to start on the side that actually has, if you look in the top left-hand corner, infinite algebra 1. And like problem number 1 should look like, geez, can I do this? It should look like this. I'll do one in this color and one in another color so we can kind of separate them. This should be the number 1 you're looking at. If you're looking at a different number 1, you need to flip the paper around because you're looking at the wrong one, right? All right, so if you remember from our stuff all throughout this year, these are actually in the nice format, right? I'm hoping there are people in the room right now who could look at that and be pretty confident, hey, I think I know where to start my graph, or maybe the blue one, or even the green one. And then once maybe you know where to start the graph, you may know something about slope, and that can kind of direct you on how to go up so many and over so many, or down so many and over so many. We're going to try to do that today. This is the nice version of what we did yesterday, right? What we did yesterday was a big jerk face question because the x was over there with the y, and the plain old number was over there with the y, and the thing equaled 0. And that made us do all sorts of extra work to get everything scooted over to the right-hand side. But this is awesome. It is in slope, intercept form, right? Okay, we're going to test you guys' mental abilities. Super early in the morning. Is there a person who feels confident that they can tell me where we're going to start? Let's look at the blue one. Start the first dot for the y equals negative 5/3 x plus 3. Mr. Amari, what do you think?
The blue one?
Yeah.
Positive.
Positive 3. Now we've got two positive 3s. See, Coy has his little mouse right there. On that positive 3, Coy, take it to the other positive 3 that would be on the graph. There's two positive 3s, aren't there? 3 to the right and 3 up. Which one are we looking at?
On the y-axis.
And the y-axis is the one that goes up or the one that goes side to side? Wonderful, up and down. So, Coy, if it would be so awesome. Can you do that, or do you need me to do that? I don't know how easy. He's dragging the dot.
Get bigger. Okay, just bring it down to the same spot.
Okay. We're just, there we go. Lars is in charge. We can see it now. If you are not putting this on your paper right now, I should see it with my eyeballs. I should see the dot on your paper at 3 on the y-axis. I'll label it if you need me to. The number that's always, always, always being added or subtracted at the very end is called the y-intercept. If there's no number there, we would start at 0, right, on the origin. Okay, this is just the starting point. And then the fancy word coefficient, or whatever is being multiplied by the x, gives us some instructions on how to proceed. Someone who's not Amari, have any type of suggestion here, panel? How are we going to proceed after we get this first dot there on the 3?
We're going to go down 5 over 3.
Okay, she said down 5 and over 3. Can you tell me what made you think we were going to go down? Why didn't you say up 5 and over 3? Because it's negative, right? Negative is going to tell you to go down, and then positive, if it was, which this one isn't, it's going to tell you to go up. So Coy's moving down 5, 1, 2, 3, 4, 5, and then he's going over 3. He's got it pointed in the right spot. All right, well, that's a lot better dot. I'm going to make it blue just so it's like the other one. Now, I don't know if you all have space on your graphs to go down 5 more without running off the page.
No.
But like on mine, I probably could have Coy go down 5 more and over 3 more. I mentioned quite a bit, like back in the olden days when I was in school, they said you need to have 3 dots to make it a line. And so if this was my graph and I had room, I would go down 5 more and go over 3 more. Over is always, always, always to the right. We never go to the left, right?
Yeah.
And we're getting there. We're making progress. Now you maybe don't have the ability to do that. You might just only have the 2. And I'm going to go ahead and with the best of my abilities, without a ruler or anything, I'm going to connect them to make a line, put arrows on the end, because really it goes forever and ever, ever. And we graphed perfectly the blue one. Okay. So we have the blue one on there. Our next target is to find out about the green one. And we're hoping to find where the green one and the blue one cross or intersect. And the spot where they intersect is going to be the answer. Mr. Sewell.
So on the side,
Okay, if you didn't hear what he said, so you start at negative 3. And which negative 3? The one on the x-axis?
on the y-axis.
Okay, so 3 places down from the origin, right? Look at Boy, he's on it now.
And then you gotta go up 3 and over 3.
Okay, whoa, I want you to repeat that again. Tell me again about what you're doing up and over.
So you gotta go 1 up on the y-axis.
Uh-huh.
And then you go 3, positive 3 over on the x-axis.
Okay, so you said up 1, right?
Yeah.
Okay, I thought you maybe said down in a second ago, that's why I kind of freaked out. You said up 1 and then over. Over is always to the right.
Oh, look at that. They land on the same line.
And hey, we've already found the answer, didn't we?
Yep. That is 3 and negative 2.
So, just for the sake of completing the question, as soon as Coy gets his answer on his paper and everything, I'll have him connect the dots. Like, hopefully you connected the dots on your paper already. And we're looking for the spot where the lines cross, if they do, which in this case they obviously do. And that spot where the lines cross is, Amari says 3, -2. Our perfect answer. Whoa!
That's great.
Oh, his arrows are better than mine, though.
They are. Oh, I do those too.
So,
So do I.
3 to the right, 2 down is 3, -2, right? 3, or this is like x equals 3 and y equals -2. You could also say that. If you really wanted to check your answer, let's say you're not the best person at graphing, and your skills at graphing are okay, but maybe you're not as confident as everyone else, or as confident as you are in other things. And if you're okay at adding and subtracting, multiplying and dividing, you could, if I wanted to check my answer, I could take 3, put it in for the x, and take -2, put it in for the y, and I should get a true statement. Not just in this equation, but also in the other equation. Like I'll show you, let's just say, for example, I'm super nervous, I'm doing this question on the math test, I have no one to help me, I'm not in a room with 15 other people who can kind of help me out if I have problems, and I want to make sure this is my best answer possible, right? I'm going to, kind of out of space. I'm going to take 3 and put it in for the x right there. I don't know where I can do that. I'll just kind of do it over here. 1/3 times 3, and then do subtract 3 from that, and see if this equals what the y number is, -2. And so I can work that out really quickly. 1/3 times 3 over 1 is 3 over 3, right? 3 over 3 is same thing as 1. Does 1 minus 3 equal -2?
No.
Yeah, it does. 1 minus 3 is -2. So it works in the green equation. So I know I graphed that one right. It should also work in the blue one. So if I quickly erase this, without messing up my graph too much, I can take 3, put it in for the x right here. Oh, 5/3. Gross. I'm going to do 3 over 1 to make it easier. Plus 3. And see if it equals -2. Oh. Okay, maybe you're one of those people who cancels stuff out here, right? Maybe you've done that before. And you've got -5 over 1, which is the same thing as -5. Does -5 plus 3 equal -2? Yeah. And so it works, our answer for x and y works when we plugged it into both equations. If it works in both, and you get a true statement in both of them, you know 100% that we have it right. There's no even guessing, oh, I think I got it. No, we know we got it.
Yeah.
And we're good to go to the next one.
Unless you math.
All right, unless we made a mistake with the multiplying stuff. All right, wonderful job on the first one. Let's look at number 2. Give me 1 second to get it written. And
I'll give you 3.
look at that.
Handy dandy.
3 seconds. Okay. I guess we're going to have black on this one.
Black with blue.
All right, black and blue. Alrighty. So let's look at the black one first. Someone whose name hasn't been used yet. Mara, I know you've been awesome at this. Is there someone who I haven't called on yet? Or I can just pick somebody. England!
Yes.
Out of the black one.
Yeah.
Y equals 4x plus 3. You are going to hopefully give me some piece of information about how to start it, or maybe you could even do the whole thing. How will we start?
You will start on the positive 3 on the y-axis.
Wonderful. Make sure Coy does this right. Does that look like the spot where you wanted to put the dot?
Yes.
Yeah.
Okay, everyone else, if you haven't put a spot at 3 on the y-axis, go ahead and put it in the same spot for you. Hang on. Okay, Tina, let's keep rolling here. Where are you going to go from that spot?
4 over 1.
Okay, say that one more time. I heard.
What is these? 4 over and 1?
Yeah.
Okay, so the number 4 could be 4 over 1, yeah?
Yeah.
Boys, giving you a visual. So that's something you go.
Up 4
Up
over 1.
Now, here's the problem I see, guys. I'm looking at your all's graphs. Like, going up 4, you're kind of off the graph on yours, aren't you?
Yeah. I'm going down 4.
So here's what I would do. I would go kind of freehand up 4 and over 1. Or if you want to like make the little notches for yourself, Or if that's going to be too kind of sloppy for you, I never do this, but you could go down forward into the left one, do the complete opposite of what we would normally do.
That's what I was saying, why no?
Yes, I don't think
Because
you're just ignoring.
Right, it's still the same thing.
The other way.
I mean, all year I've told you guys just to do up and to the right and say always go to the right. Just to make it the same thing every time so no one is confused. Now you obviously can't get a third dot on there unless you went down to the left. So let's just for this one, because we're kind of off the graph, go ahead and connect the dots with just two. Oh, that'll be good enough. This one is super steep. Look how steep a slope of 4 is.
oh,
Like the number 4 by itself, if I asked you, hey, is the number 4 a very big number?
No.
You're like,
No.
man, it's not even, you know, double digits.
Yeah.
But when we talk about lines and we're talking about slope, a slope of 4 is actually super steep. Like that is incredibly
It's
steep.
like 100 is like really steep. Like, that's like this way.
Right. Slope of 100 would, I mean, it'd be almost straight up. It would be almost impossible to graph. All right, Hannah, I heard, or I saw you were going to help me on the black one, but maybe you can help me on the blue one. What do you think about the blue one is a good location to start our graph?
Negative 2
-2.
on the y-axis.
Now, Coy is going to hopefully have it change to blue. Look at him. Ballin'.
You know, it's uninterpretable.
Okay, now this one is a little bit tougher. I think it's not going to fool too many of us.
I got
This, whoa, the slope is not quite as obvious. It's not like there's a big number. It's just a negative sign. So Hannah, what?
Down 1, over 1.
Okay, so what she kind of already knew what I was going to ask her there. If that is kind of bothering you because there's no number and you really like to see the number, you could. Oh man, boys, all over. If you weren't quite fancy pants enough to kind of get what Hannah got and what Boy got, you could say, oh wait, a negative without any number on it is the same thing as -1, right? And you could make it a fraction. -1 over 1, x. Remember, negative is going down, and we have room to go to the right. So I would go down 1, to the right 1. Now, Coy's lines aren't quite long enough right now, so you're really going to have to, he's going to go back to the black line and extend it a little bit longer, because right now, holy cow.
Boy, you can do it. Problem solving with boy problems. It stops at negative 1. Yeah, right there.
Yeah. Now, did you see what he was doing? He was actually trying to eyeball it up. What he could have done as an alternate strategy, just instead of just trying to eyeball to where it looks like it was straight, he could have continued the slope. Remember, it was 4 over 1. He could have gone down forward to the left 1, down forward to the left 1, and seen if that could have helped him as well. He did. I think he got it though. Let's see. 1, 2, 3, 4 over 1. See, like here's the dot. This is extra, and then you would have gone down 4 more and over 1. He's got it in the right spot.
Negative 2.
So even though we kind of had to freehand it there a little bit, this spot right here is from the origin, 1 to the left, and 1 down. Tanner, you just said. What is that again?
-1, -1.
Wait, how does it not write when you have your finger on it?
Whoa! About messed that up. -1, -1. I about did. What? Now, I'm not going to double check this one like I showed you on the last one, because obviously we're all doing it together and we've done enough.
We do all of them together.
I'll do one more of these. Actually, there's one that's kind of tricky on here.
Do that one.
Let me skip to that one really quickly. Let's go to number 4, because I'm pretty confident at what I've heard and seen from you all so far, that you can probably get the rest of the front side here all done by yourselves without much help, with one exception. Let's look at number 4. This one looks a little bit strange.
Oh, I know it. Is that the order?
Just get it out of there.
Just let it disappear.
You tried to drag it off stage, like yanking someone with a cane off stage. Number 4. Look at this.
I know what.
Wait, no. Need a different color. So obviously, something is up with that first one in red. We're totally missing something, right?
-1, that's it.
All it is y equals -1.
So it just started at -1, that's it?
I think so. Amari had your hand up though. What were you going to say, Amari?
Yeah, it starts at 0, the origin.
Well,
Right.
No,
look at what they're
Right.
giving us.
Yeah, the right says that.
it'd just be at -1, that's it.
Right. The thing that we're missing is not the y-intercept. You see how we have a plus or minus part?
We're
Yeah.
missing the rise over 5.
Well, yeah, we're missing the part that has the letter x. We're missing the part that tells us, hey, I'm going to go up so many and over so many. To be honest, could I have written it this way? Would this be a different way to write the equation? Could I write this as, I don't want to do green. Get out of here.
Green.
Green. Could I have written it like this? 0x's minus 1?
Yeah.
Right? That's basically the same thing. And if it looked like that, now would it be
Yeah.
a little bit easier?
Yeah.
So this one is starting, Tanner, you said it a second ago, at?
-1.
Uh-huh. And then if the slope is 0,
So you
Just
don't
keep
go
going down.
nowhere, and then you go.
It'll be a no solution.
Then you go down.
Yeah, because it'd be,
No solid.
it'd be down or up 0, and then just.
and it's like 0 over 1. I'm going up 0 over 1. Or you could say down 0 even. Down 0. It's a flat line.
You be on the same line every time.
It's just like this. Completely. I could do this forever and ever if I wanted.
But no, but there's.
So no solution?
But we don't know that yet.
So, cause that line right there is called that. It's 2, 1 by
Yeah.
I mean, look what we did basically. Didn't I just go, didn't I just go to the y-axis? Isn't that line just like a completely flat line that is like a giant line all the way across -1? That's, I just basically divided the thing at -1. The y-axis just kind of split right there at -1, completely flat. So that's really awkward, but we've never really practiced one like that before. Okay, someone who's a little more confident here. Something you think you can help me out here on the Friedman? I think you got confidence. Could you give me your best guess at where we would start the green one? Look at that, he did know. He was just cheesing me.
Oh,
+4.
I'm like this.
So 4 places
Oh, look, it
above.
already intersects.
Yeah, it's not, we already have the answer, we don't need to work anymore.
What do you mean you already have the answer?
Because it goes all the way down to that first point right there.
Oh, well, you've done it, but I don't see it on the screen yet. So,
Once you do the rise.
okay, Tanner, or not Tanner.
Yay.
Chris, where are you gonna go once you get to 4?
Go down 5.
Okay, he says down 5. And then what?
Over 2.
Oh, hang on, Chloe, you did the over part.
Told you.
Oh, there it is the answer. Right, okay, that's what you were
Right.
saying.
Well, it still intersects.
So even though Chloe is being awesome here to put the third spot, he really, for the purposes of this question, didn't have to. Like Mari said, once we saw the point where it crossed, we technically have the answer. Look at that, using a perfectly straight line.
Cheater.
He's even gonna try to make it green. There's arrows. Extra credit for this guy right here. So, no, I'm just kidding. The spot where it crosses is,
Plus 1.
is that 2 to the right? My eyeballs are failing. 2 to the right and 1 down?
To the zeros.
What are you saying 0 for,
I
Mark?
don't know why is this 0. Question.
This is from the origin, 2 places to the right, and 1 down.
2, -1.
2 places to the right, 1 down. Question for the
I
audience.
saw you right.
Question for the audience. You feel like you can go
No.
without me?
No.
I
I
think
messed
you
up
did.
on 1. See, I could have done that wrong.
Yeah, we're being.
Yeah, no, we can't.
Alright, so I'm gonna zip my lips. Go ahead and try to get the 5 other ones on this side. Don't worry quite so yet about the back side. I just wanna make sure that you're doing this side correctly. So once you get done with the front, the 5 other ones on the front, I want you to show me what you've done, and then I will look at it, and then if I think it's good, you pass my inspection, then I'll let you flip it to the back and try the ones on the
I
back.
thought you were gonna special. This is me both.
stuck? Let me know. Civil. Thanks, he's stuck already.
Boy, Jones.
It's negative 1/2. So you go down 1/2. But your other one's
Down
right.
over 2 or down over 3?
Really quickly, I had some people looking at number 3, where it has negative 1/2, and they kind of put the negative sign a little bit differently than I do. Like, look where I put my negatives up on top with the 5. They put their negatives kind of out in front of the fraction. Don't let that freak you out. Just kind of move the negative up to the top. So you're going to go down. Anytime you see a negative sign, you're going to go down, but you'll still always go to the right. We are never, never, never going to go to the left unless for some reason you are off the graph and you just hate freehanding it. But you'll always go down and to the right if you see negative.
Yeah, she is.
Which number is telling you the starting spot of your graph? You were in zombie land. Number 10. This. When you start on the y-axis. Where's Megara?
Mari, remember how we were talking about that old kid show the other day? We couldn't figure out what it was called? Yo got the camera shit.
Oh, yeah, I remember.
That was my show. Bunch of furry costumes.
She knew.
Oh,
That's you still watch it.
you ain't watching it.
Negative 1/2. So down.
This is a P-rated classroom here.
I know.
G-rated.
Did you go down?
Yeah.
The dot that you already made, not the you already made.
No.
Oh, God,
Ping pong.
On this one, when it's negative X, plus 1 would that be negative 3? And then wait, I need to know what number 6. Yeah.
Did you get it?
You know how there's always that one
Okay,
person
now
that
take
has
down 1/2 from that piece. Go down 1/2. Yeah, so you have to mix a straight line. If you don't mix a straight line, you're
Still.
Okay, wonderful. Just look at the bottom.
I'm done.
What do you think? Go down to positive 1 4. Go up 1 over 4. Up 1 from here.
No, it is.
4.
Oh,
You're just